We are going to be looking at a problem from section 5.4. This is problem number 23, and this is on insurance premiums. What you see on the screen is an abbreviation of what's all included in this problem, and as I'm reading through this, you can see how what we have. Let me read the entire problem from the textbook so you can get a better feel for what it says. It says the table below, or on the side, gives the annual premiums required for a $250,000 20-year life term, 20-year term life insurance policy on female non-smokers of different ages. What we want to do first is find an exponential function that models the monthly premium as a function of the age of the female non-smoking policyholder. That's part A. And part B, we want to find the quadratic function that is the best fit for this data. And then C, we want to graph each of these on the same axes with the data points to determine visually which model is a better fit for the data. And they tell us to use a window that's the X window goes from 30 to 80, and the Y window goes from a Y scale goes from -10 to 6,800. And so let's begin this problem. To begin this problem, one of the first things we need to do is to get our calculator a little bit bigger here. So I'm going to get the calculator bigger. And then the next thing we want to do is input our data. So I'll turn the calculator on. And if I go to, let's go to the Stat menu. What I want to do first is clear out some lists here, just for something different. Let me clear out lists 3 and 4. So I'll do second, list 3, comma. I have to enter first. All right, now I do second, list 3, comma, second, list 4. And so I'm going to put my data in lists 3 and 4. Now we go back to Stat, and we are going to edit, and we can see that list 3 is empty here. So let's put in our ages. That'll be our X's for this. And so the first age is 35. Enter. 40. And then 45. 50. 55. 60. 65 and 70, and finally 75. That was the easy one to enter. Now let's scroll over, and under the L4 we're going to put the premiums. The first one is 145, next one is 185. Now these are monthly premiums for a $250,000 term life insurance. Next one is 253. Next one is 363. And hopefully I'm getting all of these right. The next one is 845. And then we have 1,593. And 2,970. So as this female ages, the premiums are going higher, and that should match it up. So let's double check. Everything looks pretty good. Now we want to find an exponential model for this. So we're going to go back to the Stat model, or the Stat menu, and this time we're going to go to Calculate. And we want to find an exponential model, so I'm going to scroll this thing down, and we want to get to the exponential regression. That's letter 0, number 0 here. So I'll hit Enter. And in this particular situation, my X values are in L3, so we'll hit second L3, and we'll hit comma second L4, because that's where the Y's are. And so this gives us, I thought I hit Enter. This gives us our answer. Now, I'm going to set up the pointer here a minute. And I got to get this set up, and unfortunately I have to have things running before I can do this. And let's just use a dark color here. Now, I want to write this down because eventually I want to use it. And so when I get over to here, the model that we have then, this exponential model, is going to be y is equal to a, which is 4.304, and then that's times, and then we have a B number, which is 1.09. Let's keep one more digit, 6, and this is raised to the x power. That's our exponential model. Let me get that x better. I'm going to write one other thing down here while I have it. I'm going to have my r squared value is equal to 0.974. Now, in addition to the exponential model, we want to come up with a logarithmic model. In our log model, we're going to go back to our calculator. We're going to hit Stat, and we're going to go to Calc. And then, for the quadratic, we're going to go down to here to number 5 for the quadratic model. And we'll hit Enter. Then we have to again tell the calculator where our x's are. They're in L3. Comma, tell it where the y values are. They're in L4. Once we hit Enter, we get an answer again. Okay? Now in this one here, our model for this one is going to be, if I can get this going, y is equal to a, which is 6.182. And this is times x squared. Then we have the b, which is a negative 565.948. Now this is actually more precise than I would care for. And then we have plus the c value, which in this case is 12,810. So I have 12,810, and that's all I have room for, so I'm just going to quit it there. I want to write down my r squared value once again, so for future reference, this is 0.942. Now, the next thing they ask us to do is to graph each of these things along with the scatter plot. So let's go back to the calculator. And in the calculator, on our stat plot, let's go to second stat plot, turn that on. And we want to turn it on, and for this particular problem, my x's are in L3, so I have to change that. Scroll down, and my y's are in L4. And so this looks like it's good for the scatter plot. Now we're going to hit the y equals, and let's put in the exponential model first. So this is 4.304 times, and then we have 1.096 raised to the x power. And if I want to add it to this the quadratic model, this one here was 6.182 x squared, so I'm going to have x squared, and then we have minus 565. This is 0.948. I think that's what we have. This is times x, and then we have plus 12,810. And again, this is a little more precise than we want sometimes. But now let's set up the window. The window that they wanted us to use, looking back at my book, my x-min should be 30, and my x-max should be 80. So these are the ages, and so for all this here, we wanted a number less than 35, and we wanted a number bigger than 75. Let's use a scale of 5, because in our table everything over here is by multiples of 5. And continuing, the y-min they wanted us to use was negative 10. And the y-max they wanted us to use was 6,800, so this is a big number. I think the only reason we had the negative 10 instead of using a 0 is so we could see the axis better. So this is going to be 6,800. And on this, let's use a scale. I'm just going to use a scale of let's use a scale of 500. Now that's my choice. Here we go. Here's what the graph looks like. There's the points. The first one, our y1, was the exponential model, and we can see that's fitting fairly close. And then we have the quadratic model. and we're asked to determine which one is better. These are both fairly close, but initially the exponential model is quite a bit better than the logarithmic model, than the quadratic model. And so I'm going to say that I think for this particular one, the exponential model is going to be better. Now, this can also be determined by looking at our r-squared values. The closer the r-squared is to 1, the better the model. And so we have 0.974 over here, and over here we have 0.942. So we can see that the exponential model is slightly better. This completes this particular exercise. Problem number 23 from section 5.4, looking at and comparing an exponential model and a quadratic model for life insurance premiums.